So my plan for today is I have some practice questions for us to kind of work through and practice on. So I was just gonna, I have them written up here. They're in the OneNote too. If you want to look in on your own tablet, it's fine. But I've got them projected. I'm just gonna give you guys a little bit of time to try the problem, then we'll go through it. We're just gonna kind of go, and I'll just kind of watch how you guys are doing, and if you're continuing to, like, it looks like people are making progress, I'll let you kind of keep working at it for a bit. Everybody kind of just looks like, I'm just waiting for this to be over because I don't have any clue what to do. I'll probably wrap it up soon. Yeah. Sure. Yeah, no problem. So you should have like something to write on. Scratch sheet of paper, separate sheet of paper, like a OneNote tab on your tablet, wherever you want to kind of do your doodles at. But you should try to work through this stuff that we're going through together. I have like 4 or 5 things that I thought would be pretty good ones to practice on. And after that, I'll take general questions from you guys, whether it came from old homeworks or multiple choice questions or free response questions or, this, that, and the others. Or just general stuff. There'll be time at the end to do that. So these ones that we're going to do here, I think would be good ones to make sure that like kind of understand these concepts or like get what you can do or not do with something. This may be just really trying to give you some pretty helpful hints on test time. So like definitely want to participate. Make sure you kind of go back through something like this if it's not like it doesn't click immediately like what to do. So the first question just says, which one is differentiable? And I give you 3 piecewise function options. I guess we'll call these A, B, and C. And maybe I should say like, it could be more than one, right? I don't want to say like, there's only one of them, like which ones, maybe singular, maybe plural, are differentiable. So take a couple minutes here, kind of work through what you can do, and then we'll talk through and I'll go through like what exactly I'm checking for, how to check this here in a moment. Yeah, no.
All these questions that we're doing are these stuff that we might be able to expect from us.
I would think that you should be able to do, if I'm making a point of doing it on a review day, that these are things that like, I think that this or something very similar is likely to find its way on.
Okay.
Or something that uses the same concept or whatever, right? Or the same technique or the same trick or the same problem solving strategy. But like I'm clearly choosing these for a reason. You know what I mean? Yeah, no problem. And you can ask about stuff like that. I'm happy to like, I don't want to be like, it's going to be exactly this, but it's going to be like, if you understand this, it'll certainly be helpful. Like extremely helpful. Why isn't it differential? Because it's not differential. So helpful.
Now just
Number two.
Yeah,
Number
sure it is.
two.
It's C.
Number two.
I forgot. It's C. It's C. There's no way to.
Yeah, I know it's why.
I'm smarter than everyone.
Yeah, chill.
Yeah, it's C. It's C. It's just C, because B, if you find the derivative, it's that way.
A is differential.
Okay.
Two X plus one.
So
I got you.
So let's start talking through things, yeah? You guys ready?
Yeah.
Okay. What's the definition of differentiable? Go ahead.
When it's continuous and the derivative.
So differentiability implies continuity, but what you need to check, or what differentiable really means, is that the derivative exists. In this case, if we say, is the function differentiable, it would be for all values of x. Okay? Does the derivative exist for all values of x? Everybody's good with what I mean by differentiable? So these are all piecewise functions, right? If you look at the pieces of the piecewise function, each piece is a polynomial, right? The derivative of a polynomial is going to be another polynomial. The domain of a polynomial is all real numbers. So each piece is going to be differentiable for sure. The only thing I have to worry about is where they join together, right? Everybody good with that? So for differentiability, all I'm going to be checking is at x equals 1. Everybody's good with why I'm doing it? Just that. Now, what are the 4 different ways that a derivative can fail to exist? At a corner, that's 1. Vertical tangent, that's 2. Discontinuity is 3. And then a closed interval. So if you have like a solid start point, like the square root function, that the closed piece would fail to be differentiable. Now, if these are polynomials, the only things we have to worry about are corners and discontinuities. Because you can't have a vertical with a polynomial, and because the domain for each function is all real numbers, I'm not going to have, a closed interval somewhere, right? Brooks.
Are we looking for questions like these? Do you have to figure out if they're continuous both at their original function and at their differentiated function?
So we're going to talk about exactly how to do what we're just kind of talking through, like what this question means and what we need to check for. We're going to do the specifics in a second.
Yeah.
Which is what you're asking about. Okay? So 2 things that I'm checking for then. I need to check for continuity in the function and a corner for f. Everybody's good? So if I look at if I look at A, is A continuous? No. The left-hand limit as x approaches 1 is 1. The right-hand limit as x approaches 1 is 2. That's a jump discontinuity, right? Everybody see that? So A is not continuous, and as a result, what can we say immediately about it? Yes, good. Okay. If I look at B, is B continuous?
Yeah.
Yes. And if I look at C, is C continuous?
Yeah.
So does continuity imply differentiability? No. So that alone on itself is not enough to conclude anything. Okay? All I know is there's not a discontinuity there, so I know it's possible this is differentiable still. What do we still need to check for?
Derivatives.
A corner, right? To check the corner, what I'm going to do is I'm going to take the derivative of my piecewise function. So the derivative of a piecewise function I can just do by taking the derivative of each piece. What's the derivative of x squared plus x? 2x plus 1. And the derivative of 2x is 2. Notice I'm going to not use an or equal to because I don't know if I'm actually differentiable here or not. Is everybody okay with what I did? What's the derivative from the left? It's 3. 2 times 1 plus 1. What's the derivative from the right? 2, right? What does that mean if they're not equal? That's a corner, right?
Is that saying when x is greater than 1, it's always just going to be 2 even though that's nowhere to plug in x?
It means that that part is like a linear function, has a constant slope of 2, right?
That's slope of 2?
Mm-hmm.
Okay. So it's basically 2x.
Which is exactly what it was, right?
I don't know if it's like a straight slope like that or...
So it's the derivative would be a horizontal line that after 1.
Okay, I'm just confused since like there's nowhere to plug in the x. So.
Right, but there's no way to plug in x if it's y equals 2, right?
Yeah.
The y coordinate everywhere is just 2,
okay.
right?
Yeah.
Okay, let's look at the C then. We'll do the same thing, check for my corner. What's the derivative from the left? Well, it's 2, right? As we approach 1 from the left. And what's the derivative from the right? 2. Those are the same. What does that tell you? No corner. And then we've eliminated all the possible reasons why it might not be differentiable. So we know it's going to work. Does that feel okay? We already eliminated vertical tangents and closed intervals because of the nature of the problem, right? Because all my pieces were polynomial, I can't have a vertical tangent. And because my domain for the functions were all real numbers, I can't have a closed interval to worry about. I'm good. I've eliminated all possibilities for C as to why it might not be differentiable, so we know we got it. Brooks.
Confused on B. How would that one in the corner if when you plug in 1 it would be 3, but then it's always 2 on the other one? Wouldn't that be a jump? Discontinuity or?
Well, those are the slopes of the derivative. So it's continuous at 1, but the slope of 1 is coming in at 2, and the slope of the other is coming in at 3. So it's going to make a corner there at 2.
Oh, okay.
Right? Because the derivative is telling you about the slope for f.
Okay.
Right? But yes, the derivative then has a jump. If you look at the graph of the derivative, there's a jump. But whether it's defined or not is what we have to check.
Do we care if the derivative slope is continuous? Is that?
We do not. A continuous function doesn't guarantee the derivative is continuous.
But doesn't that matter for our question though? If the derivative is continuous?
No, unfortunately.
Okay.
Yeah. So the continuity of the derivative is checking whether there's a corner in f, and that'll tell me whether the derivative is defined or not. But like the left-hand limit of not having continuity at the derivative might not be because of a corner. There can be other things going on, but it's like kind of a higher level question than beyond the scope of this class. But that's how you'd approach a question like this in checking differentiability. Do you guys feel okay with that? Okay, so you check continuity with f, right? And you check a corner with the derivative, right? And the corner check looks just like the continuity check. You guys cool with that? Okay. So my next question is kind of a, what else does differentiability give you? So if I have a function is differentiable, what else can we say about f of x?
That could possibly be
Okay, yep, we can say that. F is continuous. Okay.
it's possible to take the other differential of that one.
We can't say that the derivative of f is differentiable.
Okay.
That's not guaranteed. Your example would be like like the x to the 3 halves,
It's sort of a random question.
or the absolute, yeah, go ahead.
Sorry, I was just wondering, are we gonna have the equations for like quotient?
You get nothing, because the AP exam will give you nothing. Yeah. Okay, what else can we say? What else does differentiability give you? Yes, Meredith.
There's a finite slope.
Okay, so let's write that differently, right? So differentiability means that the derivative exists, right? And how do we write a derivative exists? Like, what's the definition of a derivative? The limit as h approaches 0, f of x plus h minus f of x all over h, exists. Or there's another version of this, right? The limit as x approaches a of f of x minus f of a over x minus a. Right, those are the definitions of a derivative. We've translated that differentiability into a limit equation. Everybody's good with that? What about continuity? What else does continuity give us? What's the definition of continuity? The limit as x approaches a from the right of f of x equals the limit as x approaches a from the right of f of x equals f of a for all a, right? That's our definition of continuity. What about these two things together? What does that mean? What does that tell us? The limit exists, yeah. So we're just kind of talking through, like, symbolically, what is differentiability giving us, right? What other limit things can I say about f from that? Does that feel okay, guys? So again, like, you might be given differentiability in the problem, and you might need to generate some limit statement as a result. Does that make sense? So just kind of going through some of the limit statements that you might be able to come up with. Yes? So the derivative of f at a is the same thing as the slope of the tangent line to f at a. So you can say that, like, you can say that. Like those two statements are equivalent. Yes. Sure. So you can say if it's the function is differentiable, then it has all non-vertical tangent lines, or right? You could say that for sure. Does that feel okay? So I don't know, that's a good chunk of stuff. All right, if k of x is equal to f of x times g of x times h of x, what is k prime of 2 if f of 2 is 1, f prime of 2 is negative 1, g of 2 is 3, g prime of 2 is 1, h of 2 is negative 2, and h prime of 2 is positive 2?
Oh, wow. Yeah.
So take a minute, kind of work through this. Noah, this is exactly what you're talking about, right?
Yes.
Okay. Noah's asking me about this type of problem before class started. I'm like, funny you should ask. Just table that for a few minutes, and I was planning on doing an example like this. Is there plus or minus?
No, like after the f derivative of g times h, is it plus?
I can't really make it any bigger without losing things off the screen. I'm not sure exactly where you're pointing at. I don't see any plus signs anywhere.
It was just in the equation, like not on the board.
Oh, you mean in the product rule?
Yeah.
It's plus.
Plus.
Sorry, I was really confused at what you're asking me. I'm
I
like,
just forgot.
there's no plus signs anywhere on the board. I don't know what he's asking for. I'm like, I know my penmanship is bad, but goodness gracious, where's the plus he's seeing? The T on the what? I'm like, he can't possibly be confused by that. Uh-oh. That's 3 people with 3 different answers.
Yeah, I think mine was one.
Same.
All right, should we give this a go? Sounds like everybody's kind of wrapping up their attempts at this. So, 2 different ways to approach this. When we have 3 things, I'm going to think about either like one function and then a second function, or you could think about like the first 2 as one function and the last one as a second. Okay? I'm going to think about it this way. Is everybody okay with that idea? So the derivative of k is going to be f of x times the derivative of g of x times h of x plus g of x times h of x times the derivative of f of x. That's my first step in my product property. Now, to do this, what do I need to do? How do I do the derivative of g of x times h of x? That's another product property, yes. And then what's the derivative of f of x? Well, I write f prime of x, right? Not until I'm talking about k of 2, right, do I plug in the -1 yet. Is everybody okay? Okay. And then I do f of x times g of x times the derivative of h, which is h prime, plus f of x times h of x times the derivative of g, which is g prime, and then that last term just stays the same. So if I look at that formula, how many terms do I have? I have 3, right? I have f times g times h prime, and then I have f times h times g prime, and then I have g times h times f prime. Everybody see the 3 terms? Okay, what do you notice in each term? It's a different derivative every time, right? How many different derivatives are in the problem? 3. How many different terms are there? 3. Everything else is the same though, right? So the first one I have h prime, f and g. The second one I have g prime, f and h. The third one I have f prime, g and h. Everybody see the pattern? So if I had 4 functions multiplied together, what would I have? 4 terms, each one with a different derivative in each one, right? What did we basically just show here? This is like a generalization of the product rule, right? Does that feel okay? Okay, so now if I want k prime of 2, I'm just going to be filling in so f of 2 is 1, g of 2 is 3, h prime of 2 is 2, f of 2 is 1, h of 2 is -2, g prime of 2 is 1, g of 2 is 3, h of 2 is -2, f of 2 is -1. So I have 6 minus 2 plus 6, so 10. You guys feel okay there? Doable, Sammy?
I'm trying to confuse you at the beginning of it. It's like f of x times the derivative of isn't g of x times h of x?
Yes.
Okay. Then I just do that for all 3.
So I thought about this as 2 functions, right? I have function 1 and then function 2. So I have like, right? So there's the first product property happening. But this guy is then a separate product property, right? The derivative of g times h is another product property now. Now, do you see it and what I did?
You have to solve, you have to do the product property.
So I started on the outside first and then worked my way to the inside. That's kind of what I'm saying. So I started first with this multiplication, right? And then I did that multiplication. You see it?
Okay, yeah.
You get what I'm saying?
Yeah.
Okay. And I will be frank with you guys here. Like, the ability to kind of be neat and organized and keep track of where you are at in your problem when you have multiple of these derivative rules happening kind of all at the same time is really helpful. That's a really good skill. Like, if you are neat and organized naturally when you're doing your math work, you are rewarded heavily here. If you are willing to go like a little bit slow and do like one rule at a time, really helpful in keeping organized. Matthew.
You have to like show all that work, and can you just like you have to write the equation, write all that without the numbers, or you just skip all of that?
I would encourage you to write out the equation for partial credit purposes. So it's clear to me that I can see you doing the product property and see you doing it again. Really makes it easy for me to assign partial credit. Even if you do something wrong after that, if I can see that happening, those will be like partial credit points. As I'm grading, those would be the kind of things I'd be looking for. Now, if there's a multiple choice question, do you need to show any work at all? No. Does that?
Then this would be enough. Would this be enough?
I think this would be perfectly reasonable to ask you to do with no calculator, since the multiplications are whole numbers less than 10.
Yeah.
I think you guys can handle that, right?
Fair enough.
Okay. And then I just have a couple of like standard do the derivative kind of problems here. So again, take a moment, work on these. I'll write up some answers here in a moment. Yup.
I know we kind of covered this last time, but where it like says like what will be on our test, is that like similar? Like, I know last test it was like different.
Yeah, let's finish up with this and I'll go back and I'll read through again and make sure. I know the format stuff is correct, Emma. A, I would think is reasonable that you could do in your head. B and C, I would think is totally ridiculous to think you can do in your head. Like, those are things that I would need to write down. Just to be clear as to like what a reasonable expectation is. Like, if you're like, I can't do this in my head, I'm like, good, you should not be able to do that. A, yes, maybe, if you look at it the right way.
Would it be a complete answer to like without doing the algebra, just leave it kind of like showing that you're multiplying terms together minus.
So if this is a free response question, if you finish doing all the derivatives that you can do inside the problem, you can stop and be done.
Okay.
If it's a multiple choice question, you have to go at least until you can tell which choice it is. That's why I gave like the fully simplified answer. But if we want to work through one of these, we can work through one to where you can see, like, we can talk about where a acceptable stopping point would be. Yeah, Sam. Yeah, so that's like a whole, like, several lines. So are we ready to start going through things? Okay. So I think people are still kind of working through on their own, which is fine. I just want to put the answers up so as you're going, people can check against stuff, which again, you should do, right? Like, I am positive A is 1/4. Yeah. No, man, I don't need a quotient rule to do that. Because it's a monomial in the denominator. I just think about it, x squared over 4x, which is x over 4, minus 3x over 4x, which is 3/4. The derivative of x over 4 is 1/4. The derivative of 3/4 is 0. You can do that. You can do that in your head, which is exactly the kind of time-saving thing that you have to get good at for the AP exam. Like, if you're trying to do that with a quotient rule, you're going to run out of time on the AP exam. You have to look at that and go, I see the quick way of doing this. This is a 10-second problem for me rather than a 2-minute problem, which saves me 2 minutes to use on something like B, where I know it's just going to be a lot of writing. Like, it's going to take me time to do that.
Can you explain how you did it in your head one more time?
Yeah, I wrote it as x squared over 4x minus 3x over 4x. And then reduced each to give me x over 4 minus 3/4. And then now that's in my head. I can do that. Does that make sense, Noah? And that's the kind of, like, again, why I picked this assortment of problems. Like, I want to pick one that, like, oh, this looks like I have to do a quotient rule on it. Nope, you don't. Like, get used to looking for those, because that's such a time saver. Just like C, once you've gotten comfortable with things, C is one you could conceivably do in your head. Because it doesn't have to be a triple or a double product rule. It can be a single, right? It can just be 2x to the 3/5 times e to the x. And that maybe is a product rule you could do in your head, since the derivative of e to the x is just e to the x. It's pretty easy. But probably not before test 2 could you do that in your head. But maybe by the end of test 3, you'd be able to do part C in your head. Not realistic for you right now, unless you're like, dude, I am like a derivative ninja right now. I've been practicing the heck out of these things.
That's it, 7.
Yes, 7x to the 2/5 e to the x plus 2x to the 3.5 e to the x. Did I say 2/5? I meant 2.5.
Because it's multiplication.
Yeah, because there's a product property involved there.
So then it would be the product rule. Okay.
Yep.
So where did you get 2.5?
So x squared times the square root of x cubed is x to the 3.5.
Okay.
So when I do the derivative of 2x to the 3.5, I get 7x to the 2.5
Okay.
times the e to the x plus 2x to the 3.5 times the derivative of e to the x, which is just e to the x. That's how I get the second term. What do you guys think? Are we ready to start going through one of these? be it? Letter B? All right. So the derivative is derivative of the top times, or the bottom times the derivative of the top. So notice I'm going to write this out as its own separate step, minus the top times the derivative of the bottom, all over the bottom squared. Everybody good with step one? Okay. Now, the derivative of 3x is 3. The derivative of x, e to the x is? A product rule. You see it?
Quotient rule.
A product rule inside of the quotient rule. Yeah.
Oh.
Should you expect Mr. Kulik to pull the same sneaky crap on the test? Yes. 100%. I will combine the product and quotient rule, nest them inside of each other in the same problem. I promise you I will do this.
That's gotta be like.
Wait, how come this didn't happen on our previous homework?
It did.
It did. Oh.
You probably just missed that it happened. And what's the derivative of 1 minus x? Negative 1. Okay? Everybody okay with where I'm at so far?
Oh my goodness. Oh, you can't put 1 minus x.
The derivative of e to the x is?
Yeah.
So I have x e to the x, and then minus, the derivative of x is?
1.
1, so I have e to the x times 1, or just e to the x.
You can take x out there.
Yeah, I don't need to.
Okay. Where'd the negative 1 go?
I multiplied it to make
Oh.
that a positive. Okay, Noah, at this point, the calculus is done. If there's a free response question, you'd be free to stop.
Okay.
Right? If it's a multiple choice question, we should keep going because unlikely the answer is going to be written in this form.
Right.
So I'll FOIL out this first piece here. So 1 times 3, 1 times x e to the x, 1 times e to the x, negative x times 3, negative x times x e to the x, negative x times e to the, or negative e to the x. And then that other stuff I can just drop the parenthesis on. That's not supposed to have a squared there. And if I look to combine some like terms, I have a positive and a negative, and then that's my final answer there. Good as I can do. I don't want to rewrite it for a third or another time because it's, at that point, it's the answer that I have written above, right? Okay, so this is my warning that I promise you will see on the test a problem where you have the product rule nested inside of the quotient rule or the quotient rule nested inside of a product rule where it is unavoidable. You can't like algebra your way around it. Much similar to this problem where you have to do the one nested inside of the other. Yes, sir.
Best way to recognize that there's a product inside of the equation.
So what I would do at the start is I'm just going to go through each term and look to see how I would take the derivative of each term. And when you get to this one, you should see, oh, that's a product rule.
Because x is being multiplied by e.
Yeah. Well, actually, first I would check to make sure I can't get rid of the quotient, like I could up here, right? But as soon as I see there's a sum or difference in the denominator, I'm pretty well sunk on that. And then I'd look at each term to see if there's a product rule going on in a term. Does that make sense?
Yeah.
And I think that's really just the easiest way of kind of going through that. There's not a better way of doing it.
Yeah.
Okay, how do you guys feel on these example problems we just ran through? Pretty good? Learned some new stuff, right? The differentiability and kind of what I do with that, I think was probably a place where we were a little soft. Seems like the conceptual pieces are the places where we're like, just kind of need a little bit extra reinforcement, a little bit of extra practice. I want to do that today. That was the examples that I had picked out for you guys this last 30 minutes or so. If you guys have questions from the multiple choice or old homeworks or free responses, I'll do whatever you want from here on out. Marche?
Are you going to do C?
I wasn't planning on it. I can if you'd like me to. Would you like to do that?
It's a class.
Yeah, let's do it.
I agree with it.
Okay. No, it's totally doable. So here's the key, right? The way C is written, it looks like a double product rule, correct? Because you see three things multiplied together. We can make this easier through algebra because those two terms you can combine, right? That's really like x squared times x to the 3/2. You guys see it? So if I think about that as y equals 2 times x to the 3.5 e to the x, that's now way easier because it's now just a single product rule. So first times derivative of the second plus second times derivative of the first. The derivative of e to the x is just e to the x. The derivative of 2x to 3.5 is
7.
2 times 3.5 x to the 3.5 minus 1, right?
Oh yeah, 7x.
And you're done. Brooks?
Should be for a second.
Yep, just 1 second because I see people writing down.
Oh yeah.
Sure, go ahead. So again, like eventually, maybe by the end of test 3, this is something conceivably you'll get enough practice at doing this thing that you'll be comfortable doing in your head. Right now, I would find that really unlikely. Like Mr. Kulik can do this in his head once he makes that initial simplification.
You can do that in your head.
Yeah. Well, the e to the x is easy to deal with, right? Because the derivative of that is just the same thing. So the first term of the product rule just stays the same. And the second one is just the derivative of 2x to the 3.5, which is 7x to the 2.5, and then the e to the x stays the same, you know? So like, yeah, I can do that in my head just because of how easy the e to the x is to deal with. But you guys can't right now. Eventually you'll get good enough to where that feels like it, maybe it's something you can do in your head. All right, Brooks, you wanted to scroll up?
Yeah, so about the product rule inside of the quotient rule and stuff, you did that with the derivative of 3x minus x times e to the power of x, right?
Yeah, this is the second product rule, is right there,
That's the second product rule.
which is what's happening here.
Oh. And then you had to do that because you had to differentiate something that was being multiplied with something else. Okay, thank you.
Adriana,
I just have a question. How do we get 3.x right there? Where's the
I did 2 plus 1.5. Right?
Yeah.
What's the slope of e to the x? Is it not just like that?
It's e to the x,
Okay.
which is really, really unsatisfying. Okay, go ahead and fire away. What else you guys got? Questions? Homeworks, multiple choices, whatever. Mark?
So what's the derivative of 2 times?
2e to the x. Yep. Emma?
I can't figure out how to get 3.5.
So I did 2 plus 1.5.
Oh.
Does that feel okay? Once you say it, you're like, oh, I can't believe I didn't see that. Yeah, I mean, you could write it as 7 halves. That's fine. 7 halves is fine. I just like, if it's a terminating decimal, give me the decimal over the fraction. You know? Yes.
Adding to Mark's question, the derivative of 2x times e to the x, it's 2 e to the power of x. Could you figure that out?
Plus
What?
2x e to the x.
Plus 2x e to the x?
It's a product rule.
Okay, because I was going to ask if you figured that out by just taking the derivative of each thing that's being multiplied, or if you did the product rule.
Product
Okay. So whenever you see two different things, you always do product rule.
Well, unless one's a constant.
Okay.
Right, a constant you can just ignore. Right, 2 e to the x is just 2 e to the x.
Okay.
2x e to the x is a product rule.
Is that what
He said 2 e to the x.
Okay, yeah.
So again, like the details there matter enormously in how complicated that gets. All right, what do you guys think? MCQ it a little bit? You guys had a chance to look through those yet? I know some people have because they came and asked me about it. Sarah!
We do question 55 and 3.2.
3.2, number 55?
Yeah.
Sure. I reserve the right to tell you that, like, that's beyond the scope of what's going to be helpful on a test.
I think it might be.
But I will certainly fire that up and take a look. I will do it anyway if you want me to do it.
No,
like,
it's okay if it's not. If it's like,
yeah.
yeah.
But I will be very blunt with you about
Yeah.
whether this is something to worry about or not. Oh yeah, that is way harder than something I would put on there for you.
Okay.
It just like, this is just like an exercise in being careful.
Yeah.
So what they're doing in this problem is just suggesting to you to, like, you know, how we have, like, you know, the quotient rule written as, like, if this is like u over v. They're saying, like, let's calculate u prime and v prime separately and then plug those in to where they go, rather than doing it because those U and V are so long.
Okay.
That's kind of what it's getting at.
Yeah, that makes
And then plugging the zeros in and just like dumping them into the formula where it goes.
Okay,
But like, yeah, I wouldn't give you something that gross.
okay, sounds good. May I ask you a question?
Sure, of course. But I think that like the method they're describing is like can be helpful.
Okay.
Like that's a good method to have in your back pocket of like, ooh, is this going to be just easier if I do it this way?
Yeah.
Particularly if they're asking for like a numeric answer like this, like r prime of 0.
Yeah.
You know, like, yes, please.
Yeah.
All right. What else you guys got?
We're confident.
We could just, if nobody else has any specific question, we could just like sort of go through them as a class if you want to.
Let me find some good ones here.
Thank you.
How about 6? This plays right in with what we were doing in that first question I gave you guys. Says, let f of x be the function above, which of the following statements is true about f. The limit as x approaches 3 of f of x exists. F is continuous at 3. F is differentiable at 3. Does the limit exist?
Yes,
Yes. How do you know?
because I plugged in 3 to both functions and they both came out 5.
3 plus 2 is 5. 12 minus 7 is 5. So we know immediately that this one can't be it. A and C are out, right? Immediately. Everybody agree? Continuity, is it continuous at 3?
Yes.
Yes, because f of 3 is also 5, right? Because that's what because it's or equal to, I'd plug the 3 into this piece and get 5 again. So we know 2 is definitely it. So we can cross out 1 only. So we're now down between D and E, right? How do I check for differentiability? If it's continuous and the pieces are polynomial, just look for a corner, right? What's the derivative of the top? 1. What's the derivative of the bottom? 4. And when I plug 3 in, I still get 1 and 4, right? Is it differentiable? No. So D, 1 and 2 only. Everybody cool? Hopefully we've taken a problem that like looks rather difficult that now something you can do in your head relatively quickly, right? Meredith?
So you know how like, if it's a polynomial, then we're looking for a corner
Mhm.
to show it's differentiable. If we were looking not for a corner, like for something else, then what would the piecewise go?
So a vertical tangent, the only time you're going to get that is probably with an odd root or an inverse trig, which I don't think you'd see. Certainly you can't see an inverse trig yet because you don't have any derivative rules for inverse trigs.
Yeah.
So that couldn't happen yet. Or an odd root, right? Because like the cube root function looks like this, has a vertical tangent at 0. So, but I don't think, again, I don't think you'd see that. That's awfully tricky.
And the same for closed intervals.
Well, a closed interval would be like, it'd have to have like a solid start and end point on this, right? Because we have a strict like a one-way, like this domain is all real numbers, right? So like you can see it immediately. You can't have a closed interval because there's no start or end to this. It goes on in both directions, as small as you want and big as you want. Does that make sense?
Yeah.
So that's almost never will you see that either. Does that feel good?
Yeah.
Okay, Adriana.
This is like not really a question, but for number 5, is there a way to answer that without graphing?
Yes. You want to talk about it?
Yeah.
Okay. Brooks, you had a question too?
Yeah, but it's okay. She can go.
Okay. So Adriana asked, how would you do 5 if you didn't have a calculator? right? Valid question. What is the graph for the, so we're not going to graph it because we don't have a calculator, but what does the graph for just the absolute value of x minus 2 look like? Has a corner. Where's the corner going to be at? At 2, right? Everybody agree? Okay. If I take the square root of that, it's just going to basically make like the square root function on top of that. Did I get rid of a corner by square rooting it? No. Okay. So if I look at this, do I have continuity? Can I draw that graph without picking up my pencil? Yup. Do I have differentiability? Nope. I think that's will do it for us, right? Continuous but not differentiable. Does that feel okay? And now I kind of still graphed it, but I wanted to talk through, like, I don't actually need points. I just need to know kind of what it's going to look like, right? So, like, if I know, like the fact there's a corner with the absolute value is probably enough to be like, we're going to lose differentiability here. But because I'm square rooting a positive, because it's the absolute value around it, it's going to be continuous everywhere, right? So if I just observe those two things, that's going to be enough to be like, it's got to be A. Does that feel okay?
Yeah, thank you.
Yeah, again, like, I know I still kind of graphed it, but like, the picture says so much.
Yeah.
And again, if you just notice that there's a V and it's absolute value, so it's going to be positive. So the square root doesn't really do anything to get rid of the V. You're good. Brooks.
So I know I sort of already asked this, but for something like number 6, how is it not a jump discontinuity, and how is it a corner for, like, it was like 7 and like 4?
So here's the thing. You're getting confused between whether we're talking about F or F prime. For F, to check for a jump discontinuity, you look at the left-hand limit and the right-hand limit. So 5 and 5, right? When I plug 3 in, no jump. To check for a corner, I'm going to look at the slope of F from the left and from the right. That I'm going to use the derivative. So the derivative on the right, or the derivative on the left hand is 1, and the derivative on the right hand is 4. Those slopes don't match, so it's going to be coming in like as a corner, right? It's be like this.
Yeah, I get it.
Does that? So the derivative, if you look at the graph of the derivative, that has a jump.
It's measuring the slope,
But
not measuring.
yeah. So if it depends on whether you're talking about the graph of F or the graph of F prime. That's where you're getting turned around at. Is that?
Yeah. And then also I was wondering, can we go through a few of the trigonometry ones? Is there going to be anything like that?
Not on this test.
Oh, thank God.
The trig's on next one.
Okay.
I just
Oh, here's a good one. Number 9.
Right.
F of x is 3x squared plus 2x. What's the derivative?
C.
Whoa, this goes way back.
C, correct.
How?
What's the difference between C and D?
The X and H on the norm.
Oh, yeah. Perfect. Thank you. It's like, what the heck is the difference? So that's just the definition of the derivative, right? This is f of x plus h minus f of x over h. So that's how you would still need the limit definition of a derivative, is for like a multiple choice question like this. Is that, you see it? Again, if you know what you're looking at, that's a 10-second question, right? If you don't, that takes a minute, right? The goal is, like knowing what you're looking at. How about 11? That's a good one. fact, I think some of your classmates came in and asked me about this earlier today.
What?
11. So it says the table above gives the values of differentiable functions f and g and their derivatives at x equals 1. If h of x equals 2 times f of x plus 3 times 1 plus g of x, then h prime of 1 is equal to, what are we going to have to do here? It's going to be a product property. What's the derivative of 1 plus g of x? Just g prime of x. What's the derivative of 2 f of x plus 3? Just 2f prime of x, right?
Wait, you said this was the product property, right?
Yeah.
Okay.
So now I just do my f of 1, or I plug 1 in.
How'd you figure out h prime was the product property?
Because I had two functions multiplied together.
Oh, okay.
So f of 1 was 3. G prime of 1 is 4. G of 1 is negative 3. And then f prime of 1 is negative 2. So I have 6 times 4 times 2 is 48 or something. And then negative 2 times negative 4, so that's plus 8. So 56, I think. No, that's not right. What did I do wrong? Oh, I'm so dumb. No, I see what I did. I did a very dumb thing. There we go. So 6 plus 3 is 9 times 4 is 36. And then plus 8, that's 44. Oops-a-daisy. Neatness counts, guys, right? I screwed up a parenthesis and look what happened. So again, just like, very similar to that question I put on that we did as the review, right? With the double product rule. Here was just a single product rule, but same kind of thing. Ooh, I like this. Two differentiable functions f and g are shown. P of x is equal to f of x times g of x. Which of the following statements about p prime of negative 2 is true? So what's the formula for p prime?
F prime x times g of x plus g prime x times f.
Yep. So p prime of negative 2, that's going to be, let's write it. So that's this, right? Oh dear, what happened? Okay. So f prime of negative 2. So that's going to be that slope. Everybody agree? Positive, negative, or 0?
Positive.
Positive. g of negative 2, that's this point, positive, negative, or 0?
Positive.
The point?
Oh, the point?
That's a negative y coordinate, right?
Wait, oh, yeah.
And then g prime of negative 2 is this slope, positive, negative, or 0?
Oh, positive.
Positive. And then f of negative 2 is that point.
0.
That's 0.
Oh, so it turns out to 0.
So I have positive times negative, that's negative, plus 0. Negative plus 0 is negative. You guys feel okay on that?
Yeah.
So again, even though there's no numbers involved here, like I can't actually compute the value of p of negative 2, I can still say something about it just by looking whether the slopes for the derivatives are positive, negative, or 0, and whether the y coordinates are positive, negative, or 0. That's enough. Let's see here. Ooh, this is a good one. How do I do this?
You differentiate those and then set it equal to 1.
Well, first you need continuity, right? And then you need the corner part. So the continuity means that 1 plus b has to equal a times 1 squared. Everybody agree? The left-hand limit has to equal the right-hand limit. The corner piece means that the derivative of x plus b has to equal the derivative of a square or ax squared with the 1 plugged in. So I use the corner piece to solve for a, and then I can drop that into the continuity piece to get b.
So then a would have to be 1/2 to make b and a equal each other.
So b would have to be then negative 1/2.
Wait, I thought that. The prime of b.
But that's a good one. Again, uses that same idea that we talked about.
Wait, I thought that b was.
1 plus b is equal to a. I wrote it right here, right?
Yeah.
So if I subtract 1 from both sides, b is negative 1. Okay? You'd see it if you wrote it down, you know. Not differentiable, that's fairly easy. That's the same question, really. That's a little obscure enough I don't care about. How about 24? What does this mean?
Prime of f at 3 is equal to 5.
Right? So we're differentiable at x equals 3. Agreed? That tells me that f is continuous at x equals 3, right? So that's continuity. That's continuity. This is differentiability. This is differentiability. Order of a process of elimination says E has to be the answer. Everybody okay? That stuff's fairly straightforward. How'd you do 27? Right, I have to solve the derivative equal to 1/2. How do I find the derivative of x over x plus 2? Quotient rule. What's the quotient rule again? Use tops and bottoms. Times the derivative of the bottom. I'm going to do it quickly. Times the bottom times the derivative of the top over bottom squared, right?
Oh, you solve correct. I say plus or minus.
Yeah, I took the square root of both sides.
Why is it not 4? Or why is it not minus 4?
Well, if I do positive 2 minus 2, that's 0. If I do negative 2 minus 2, that's negative 4. Right?
Yeah.
Again, if like you write it down, it's just trying to carry it all in your head is a lot.
Okay.
You know?
Yeah, I don't know if it's like a basic math thing or.
Yeah, it's one of those, like, if you were going slow by yourself writing it down, you'd see exactly what I'm getting. Because I'm doing it fast in my head, it's less obvious. All right, should we be done?
I suppose.
Okay. Let me scroll if I see another good one. Oh, those are good ones back there. You should look at 58 also if you didn't see that. That's the only physics problem I think that made it into the review.
Good afternoon, Notre Dame Press. Let us end this day in prayer. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Where did I feel God's joy today? Let us end this day with a subtuum. We turn to you for protection, Holy Mother of God. Listen to our prayers and help us in our needs. Save us from every danger, glorious and blessed Virgin Mary. Amen. In the name of the Father, Son, Holy Spirit. Amen. Students, have a great afternoon.
Thank you, Dr.
You may dismiss that you're ready.
So we'd say it's moving down because the velocity is negative, and it's increasing velocity because the signs match. You're welcome.